In this lesson, we're going to learn how to use the quadratic formula and what it's for. You can put your heading on your paper. Feel free to pause the video at any time. We have learned 3 ways to solve a quadratic equation. Now we're going to learn a 4th. So before we go on to that, I just want you to, we're going to summarize the other 3. So can you write for me methods to solve a quadratic equation? Methods to solve a quadratic equation. Now, there are 4 ways that we are going to learn. We've learned 3 already. 1 we're going to learn now. These will be used for a variety of reasons. So the first one that we learned was just by factoring. So that's if you have a nice, easy equation that you can factor. So example, if you want to put x plus 6 times x minus 4 equals 0. If we can get the equation to look like this, and then our work would lead us to our answers of x equals -6 and x equals 4. Notice I'm skipping a lot of steps because I just want to get to the heart of what we're doing. The second way we learned was factoring by grouping. So can you write factoring by grouping? Factoring by grouping. So we would use factoring by grouping if we had a number in the front of our x squared. So for instance, our 2 sets of parentheses would look like this: 2x minus 1 times x plus 6, where we had to multiply a times c, if you remember, and find factors of that. Then we would solve this and get answers of x equals 1/2 and x equals -6. So again, we use factor because it was nice and easy to factor, and factor by grouping if we had this number in the front and we still could factor. The third way that we learned was completing the square. That ties into today's lesson, completing the square. And that's where we did those 4 steps: finding half of b, squaring it, adding, subtracting. So we would get the equation to eventually look like this. We'd have x plus 4, 5. And then to solve it, we would do the square root of both sides. And answers of x equals -4 plus or minus radical 5. So we would use this, completing the square, when we could not factor, and we would probably have a radical in our answer, or we would have a fraction. The 4th way we're going to learn is the title of the note, the quadratic formula. So can you write quadratic formula? And this takes a little bit longer, but it can be used for any equation, any quadratic equation, and you would mainly want to use this if you couldn't factor it. So we're just going to write a quick definition after you wrote quadratic formula. Can you write formula used to solve quadratic equations? And it's really important on this that you want to get the equation equal to 0, because you always want to start with it to see if you could factor it or if you'd have to complete the square. So I'm going to give you the formula, and we're going to be using that for our 3 examples. So what I'm going to do is, you might want to watch this before you write it just to see how much space you need. But this is the formula, and you might have seen it before in algebra. So it's x equals, we have a really long fraction. We have -b on the top, plus or minus. Underneath the radical, we'd have b squared minus 4ac, all over 2a. So that's the formula we would use. So what I'm going to do is bubble this and tell you where we're going to get the a, b, and c from. So this is the formula, the quadratic formula. The nice thing about this is, if we're taking the regents, they give you this formula, you don't have to memorize it. So we are going to use this formula when we get the equation to look like this. So I'm going to write on the side ax squared plus bx plus c equals 0. I'll give you a second to write that. So you always want to get it equal to 0 first. So I'm going to put that as a little note. Get equal to 0 first. That's very important. You cannot use this formula without it. The a would be the number in front of the x squared, the b would be the number in front of the x, and the c would be your constant, the number at the end. So this is when you would use this if you cannot factor a quadratic. So one more little note. This is helpful. This is helpful when you cannot factor. You cannot factor. So we're going to do 3 examples, and I'm going to space it out just so you can see all of the work. It's going to take a little bit for each one. That's why you won't have a lot of them to do. We're going to do 3 in the note. So I'm going to switch to my next page. I'm afraid I'm going to run out of room. So I'm going to pull this off, and I'm going to give you the first example. And this is example A. Can you write solve x squared minus 5x plus 1 equals 0. So the reason why we're using the quadratic formula is we cannot factor this. There's no factors of 1 that add up to 5. There's no grouping involved because there's no number in the front. And you don't want to complete the square because you can't really take half of this without getting a decimal, which becomes messy. So I'm just going to put my little formula on my Post-it so I don't forget. You have it on your notes, but I want to have it readily available. So the first thing we would do is get it equal to 0. It is. So now what I'm going to write my values of A, B, and C, so that way I know exactly what I'm using. So my A value is the number in front of the x. That would be 1. So that's my 1. I pointed to it if you want to as well. My B is the number attached to the x. This was attached to the x squared. I don't know if I mentioned that. So A is attached to the x squared. B is attached to the x, which is -5. And C is your constant at the end, and that happens to be 1. So now what we're going to do is we're going to take this formula and we're going to plug in these numbers and then simplify it. And this answer is going to be probably a radical. So here we go. X equals, going to have a really long fraction. Instead of negative b, I have a negative, and notice I'm putting -5 next to it in parentheses. The formula has a negative, so I put the negative in it. My b is also negative, so I'm going to include that. Now I bring up for my plus or minus, and the reason why there's a plus or minus is we're going to have 2 answers, like when we were completing the square. Underneath my radical, instead of b squared, I'm going to put -5 squared, and I put it in parentheses. And then -4. Instead of times a times c, it's going to be times 1 times 1. So 4 times 1 times 1. And then underneath that, instead of 2 times a, it's going to be 2 times 1. Now the hard part's done. I just need to simplify this mess. So I'm going to move this to the side. I have x equals, a negative times a negative is a positive, so I have 5 plus or minus. Underneath this radical, let's see, I have -5 squared, that's 25. And then -4 times 1 times 1, that's -4. And then on the bottom, 2 times 1, that's 2. So what I'm doing is simplifying this and making it as small as possible. I know that I can combine these 2 inside. So I'm going to combine these right now since they're under the radical. So I have x equals 5 plus or minus. 25 minus 4 is 21, so I have radical 21 all over 2. Now to simplify, I'm going to look to see if I can divide everything by the same number. There's no number in the front here besides a 1, so I can't divide anything. So I can write my answer like this, or I can separate this, because this means there's 2 answers, one with a plus, one with a minus. So one answer could be 5 plus radical 21 over 2. And the other answer, x equals 5 minus radical 21 over 2. So I could leave it like this, or I could separate. Another way, but you do not have to, I just want to show you, you can do both of them. 2 plus or minus radical 21 over 2. So that's another way that you could write that. These mean the same thing. All right, let's do another example. I'm going to take my paper off. We're going to do example B. Here's example B. Can you write 2x squared plus 7x equals 3? So the first thing I need to do, if I look back to the beginning of my notes, I need to make sure that it equals 0 first. So I have to get this equal to 0 by subtracting 3 from both sides. 3's cancel out. I now have a 0 at the end. So I'm going to bring this down, 2x squared plus 7x minus 3. Notice I can't factor this because there's a 2 in the front, and I can't do grouping. That would give us the 7. So that's why the quadratic formula comes into play. So I'm going to write my A, my B, and my C value. And you don't need to point these out. I'm just doing it because it's the notes. This is our A value in front of the x squared. That's your 2. This is your B value attached to the x. That's your 7. And your C value is at the end. That's your negative 3. So now I'm going to go ahead and use my formula and plug in my numbers. So we have x equals, instead of negative b, I'm going to bring over the negative, and the 7's next to it. I'd like to put it in parentheses just until I'm done simplifying. Then I have plus or minus under the radical. Instead of b squared, we're going to put 7 squared. Minus 4 times a times c becomes minus 4 times 2 times negative 3. There's my a and my c. On the bottom, instead of 2 times a, it's 2 times 2. Now I'm going to simplify this. So x equals, this is just negative 7. I'll put that together. Plus or minus, again, this means we have 2 answers at the end. Under the radical, 7 squared would be 7 times 7. That's 49. I'm going to do this in my calculator so I don't mess up. I have negative 4 times 2 times negative 3. Notice it becomes positive 24, so I'm going to put plus 24. All of this goes over 4. 2 times 2 is 4. I now can combine the two numbers under the radical. So I have x equals negative 7 plus or minus. 49 plus 24 is 73, so I have radical 73 all over 4. Now I'm going to see if I can simplify this. So like in the last lesson, I'm going to go to y equals and type in 73 divided by x and see if there's a perfect square that I can divide into it. So I'm going to go to my table starting with 1. And if you look, I keep going down, there's no perfect square that goes into 73. So that means this is my simplified answer. So again, I can leave it like this. I can separate it into 2 answers, one with a plus and one with a minus. That would be the same as x equals negative 7 plus radical 73 over 4. And x equals negative 7 minus radical 73 over 4. So those are your 2 answers. And you also could rewrite it by separating each of them. So you can have x equals negative 7 over 4 plus or minus radical 73 over 4. So you can have it one of 3 ways. This one, these 2, or this. All right, one more and we're done. I want to practice with rounding. So this is the last example we're doing. So I'm going to take this off and go on to example C. And I'm using a lot of paper just because I want to make sure you can see all the steps. Can you write solve by rounding to the nearest tenth? Solve by rounding to the nearest tenth. So here's the example we're using. So x squared equals 6x minus 4. This is an equal sign. All right, so we'll do the rounding at the end. First thing we need to do is whenever we're solving a quadratic equation, we want to get it equal to 0. You always do that first, so we're going to move everything to the x squared side. So minus 6x from both sides. 6x's cancel out. So I can't combine these, so we have x squared minus 6x equals negative 4. I need to move the minus 4 over by adding 4 to both sides. 4's cancel out. That gives me 0 at the end. I cannot combine these two because one's a letter, one isn't, so I'm just going to write it in order. So x squared minus 6x plus 4. I have to use the quadratic formula here, or I could do completing the square because I cannot factor. There are no factors of 4 that add up to 6. So we're going to use the quadratic formula. So I'm going to do my a, b, and c values. So a is my 1, that's in front of the x squared. My b is my -6 attached to the x. And my c is the 4 that's at the end. So now I'm going to go ahead and use my formula, and here it is. So here we go. I'm going to change x equals, instead of negative, and notice that b is also a negative, so I'm putting a -6 together. They'll cancel out eventually. Then I have plus or minus. Instead of b squared, I have -6 squared under the radical. Don't forget the radical sign. And don't forget your parentheses around the -6. And then instead of -4 times a times c, it's going to be -4 times 1 times 4. Those are my a and c's. Notice I'm extending my radical and fraction every time. And instead of 2 times a, it's 2 times 1. All right, hard part's done. Now we just need to simplify. So we have x equals a -6 just becomes a +6. Plus or minus. Under the radical, we're going to simplify that. -6 squared, that's -6 times -6, that's 36. -4 times 1 times 4. Don't feel like thinking, so I'll do it with my calculator. -4 times 1 times 4, that gives me -16. So I have -16. Underneath, 2 times 1 is 2. Now I can simplify. I can combine these two. 36 minus 16 is 20, so we're going to change that to radical 20. So we have x equals 6 plus or minus radical 20 over 2. Now, I cannot divide all of these by 2. You would think I could because all of them can have 20 or 2 go into it, but this is under the radical. So because it says to round, I don't need to simplify this anymore, but keep in mind, you don't have to do this. This we could simplify into radical 4, radical 5, because 4 is a perfect square, and then we could have changed it to 2, but because it says to round, I'm not going to do this. I'm going to separate these immediately into 2 answers and use my calculator to. So look what I'm going to do. My first answer is going to be x equals 6 plus radical 20 over 2. And my second answer is going to be 6 minus radical 20 over 2. And all I'm going to do is type these into my calculator and get the answer, since it says to round. The directions again say to round. I don't want to waste the time simplifying if I don't have to. So there's a couple of ways to do this. If you have a graphing calculator, to make it look like a fraction, you can hit the alpha, which is the green button, and your y equals. So alpha is the green button, y equals. And then number 1 means numerator over denominator, that's your fraction, so you can hit enter. So then on the top I can type in 6 plus radical 20, arrow down, and type in 2. That will give me my answer. Rounded to the nearest tenth would be 5.2. So my first answer is 5.2. Another way that you could do this, I want to show you the difference. You cannot just do 6 plus radical 20 divided by 2, because look at the answer. It's incorrect. So what you'd want to do is this. 6, parentheses, 6 plus radical 20. You're putting the top in parentheses, from arrow to the right. Then you can divide all of that by 2. Then you get the same answer. So if you're not going to do alpha y equals, if you're not going to make it look like a fraction, like this up here, if you're not going to make it look like this, then you can always use parentheses. Now I'm going to do this one. So again, I'm going to go ahead and make it look like a fraction. So alpha y equals, and then number 1, let's type in 6 minus radical 20, and then on 2 at the bottom. And we get this decimal. This round to the nearest tenth would be 0.8 because after the 7 is 5 or higher, so that becomes 0.8. So my second answer is x equals 0.8. So this is if the directions say to round. Please make sure you take a picture of this and submit it into Canvas.